Good morning and thank you. It is a pleasure to be here and bask in the reflected glory here of John's Stockholm Prize and to join this very important discussion on translation. I'm going to actually just set the stage for our subsequent discussion by sharing with you just a few thoughts. And I'm going to bring a different perspective to this discussion maybe than you've heard so far. So translational research is something NIST does all the time, and it's something I never talk about. It's both the premise of our agency and what we do, and it's something that we just don't discuss at all. And so I wanted to share with you why that's happening. So NIST is the nation's measurement laboratory. That's the good way to think about it. In fact, many of you probably still remember it from its original name, which goes back to 1901 as the National Bureau of Standards. It's one of the nation's oldest science and technology agencies. And its mission is basically to define the system of measurement of the United States. So yes, we define a second and a meter and a kilogram and all the basic units. But what NIST mostly does is take those basic ideas of measurement and turn them into practice. And whether that's weights and measure programs that are operated by the states so that when you pump a gallon of gasoline, you know it's a gallon of gasoline, or whether it's working with regulators so that if you go to get your vehicle checked so that for emissions that we know how to measure the greenhouse gases that are, or the acid rain gases that are coming off your vehicle. We can measure those accurately. And in fact, NIST has had a strong tie in the realm of forensic science, really almost going all the way back to its beginning in 1901. And that shouldn't be a surprise. We're not a criminal science agency, but of course the practice of law enforcement is deeply tied to the ability to measure. And so this tie goes all the way back to our history. In fact, the most famous case at NIST probably is actually NIST work, or the National Bureau of Standards work, on the Charles Lindbergh baby kidnapping and murder, where an NBS scientist by the name of Wilmer Souter was involved in the handwriting analysis and subsequently in the wood analysis that identified and eventually led to the arrest of Bruno Hauptmann. And in fact, Souter went on subsequently to help the FBI stand up their crime laboratory in the 1930s. More recently, NIST has been involved in a whole variety of areas, from digital data, digital forensics, nuclear forensics, DNA analysis, law enforcement technologies to protect people, a whole host of areas. And it's very natural for NIST to do this because it's embedded in our mission. And so in the context of translation, the way I tend to think of this is research, the notion of translation makes sense if you're looking at the worldview from the perspective of being a researcher. You have these ideas and the focus is how do I translate this into practice. I tend to look at it differently. The mission of my agency is putting these measurement technologies into practice, and the programs have to be designed to do that. Research is a fundamental enabler of that mission. And so our programs have to be designed to basically put these methods into practice. And one of the things we will need is a research. So we often view things as almost the opposite. We're getting a strong practitioner pull rather than a science push. And a good example of that is our work in DNA. John Butler is in the audience. I don't know where John is sitting. You'll see him, he says the butler did it on his shirt. One of the things that happened shortly after 9/11, of course, is with the attack on the World Trade Center, was the large volume of very degraded DNA material that was on the site. And this challenged the current technology in terms of being able to rapidly look and characterize and generate profiles for small samples, very damaged DNA samples. So John and his team basically went back developed and modified the underlying methodology to develop these profiles, and then didn't just write a science paper. What they did is they worked to disseminate that into the practice. They worked with manufacturers to develop the technology for that new equipment. They developed the testing infrastructure so that this equipment, when it's deployed, can be calibrated and checked and used reliably in the field. And so the whole program was designed to drive this new understanding into practice, but the research itself was a key underlying piece. So I'm looking forward to this discussion. I think it's going to be great, and again, thanks for the opportunity.